Hello students. In our last video, we have discussed about the rate of a chemical reaction. What are the units of rate of a reaction? What is the concept of rate of reaction? What are the factors affecting rate of reaction? How to calculate average rate of reaction? How to calculate instantaneous, that means rate at a particular time of a reaction. All these things we have already discussed in our last video. Today we will solve one numerical based on it. So here is the numerical. The concentration of a reactant R at different time intervals are given below at 0 seconds and at 5 seconds. We are supposed to calculate average rate of reaction R giving the product for the given time interval. Time is given to us in seconds and the concentration is given in mole per liter. Now since the concentration of reactant is available to us and therefore for calculating average rate of reaction, I will consider the formula rate average, that is equal to minus final concentration minus initial concentration upon del T. So minus, remember R2 is always the final concentration. So here it is 80 into 10 to power minus 3 minus 160 into 10 to power minus 3. Del T means 5 minus 0. Solving this, we get the answer 16 into 10 to power minus 3 mole per liter per second. That is mole liter inverse second inverse. Now here is the importance of the sign negative. Had we not used the sign negative, the rate would have got in negative. Remember one thing, the rate can never be negative. And therefore when we are using the sign minus for calculating the change in the concentration of reactant, final answer of the rate we get it in positive, and therefore we are using the sign minus, as well as it indicates that there is a decrease in the concentration of the reactant. When we are discussing the factors affecting the rate of reaction, the very first factor that affects the rate of reaction is the concentration of reactant or concentration of the product. Now when a chemical reaction proceeds, the reactant gets converted into product. As a result, the concentration of reactant decreases, that of the product increases, and this can be shown by graph. Time and the molar concentration. If I talk about the molar concentration of the reactant, it decreases. And if we talk about the molar concentration of the product, it will increase. So this indicates the molar concentration of product and this line indicates the molar concentration of the reactants. Now when we look at the figure, we can indicate two things. That is, in the beginning, when the time is 0, the reaction has not started. At that time, the concentration of reactant is complete, whereas the concentration of the product is 0. But as the reaction progresses, as the reaction continues, the concentration of the reactant decreases, while that the concentration of the product increases. Now, as the reaction process, just now we have discussed, the molar concentration of reactant decreases and that of product increases. So the change in concentration of reactants, products, these take place very rapidly. But it is only on the initial state. So change in concentration of reactant or product, initially these changes are rapid, but as the reaction proceeds, then the rate becomes slow. Why the rate becomes slow? Because the concentration of the reactant decreases. So from this observation, we can say that at the start of the reaction, the rate of reaction is very large and it decreases with passage of the time. So we can say the rate of the reaction is directly proportional to concentration of the reactant. Therefore, to increase the rate of a reaction, we have to increase the concentration of the reactant or as we increase the concentration of the reactant, rate of reaction will also increase. Once we know that the rate completely depends on the concentration of the reactant, we have to know the quantitative relationship between the rate of a reaction and the concentration. This quantitative relationship between the rate of the reaction and molar concentration was given by the law called as law of mass action, and therefore dependence of reaction rate on the concentration, it is also called as rate law. Now, what does the law of mass action states? It states that at a given temperature, the rate of a chemical reaction is directly proportional to product of molar concentration of reactant. So this is called as law of mass action. Molar concentration of the reaction is also called as active mass, and therefore this law is also called as rate law. So we are going to discuss rate law, according to which the rate of a chemical reaction is directly proportional to the active mass of the reactant. Let us consider the reaction A plus B gives 2AB. According to rate law or according to law of mass action, the rate of this chemical reaction is directly proportional to product of molar concentration of the reactant. Now we cannot solve the numericals by using proportionality sign. We have to convert it to equal to, and therefore we introduce a proportionality constant K A B. Now K is also called as rate constant. It is also called as velocity constant, or it can be also called as a specific rate. A and B will indicate the molar concentration of the reactant. Now suppose I want to define this rate constant. How I will define? Now if the concentration of each of the reactant involved in the reaction is unity, like the molar concentration of A and the molar concentration of B is 1, then obviously rate becomes equal to K. That is, the rate of the chemical reaction becomes equal to the rate constant. So how can we define the rate constant? It is the rate of reaction when molar concentration of each reactant involved in the chemical reaction is unity, and therefore this rate constant is also called as specific rate or specific reaction rate. Remember all the definitions from this chapter, they are the important ones. What are the characteristics of rate constant? Now this question can be asked us for 2 marks. Larger the value of K, faster is the reaction. So if I want to speed up the reaction, I have to keep the value of K larger. Different reactions will have different K, like H2 plus O2 giving 2H2O. This reaction will have different K, and N2 plus 3 hydrogen giving 2 ammonia. This reaction will have different K. So different reactions have different values of K. Third, at a fixed temperature, K is constant and is characteristic of reaction. For example, if a particular reaction is occurring at 50 degrees Celsius, the value of K will be constant at 50 degrees Celsius. But if you change the temperature, let's say if you increase the temperature to 80 degrees Celsius, then K will be different and will be characteristic of reaction at 80 degrees Celsius. The last one, for a particular reaction, K is independent of concentration. Now this is an important one. Why K is independent of concentration? Because K we have defined when the molar concentration of each reactant is unity. That means we haven't considered the concentration, or we have considered the concentration as 1, and therefore K is always independent of concentration. So we have seen two terms, R and K, that is the rate of reaction and rate constant. What is the difference between these two? The difference between these two, this question can be asked for 3 mark. Whenever different type of questions are asked, the very first point that you have to always write is the definition. So what is the definition of rate of reaction? It is the rate of appearance of product or rate of disappearance of product. You can also define it as the speed with which reactants are converted into product, or it can also write it as rate of decrease in concentration of reactant or rate of increase in the concentration of product with time. Whereas rate constant is defined as the rate of reaction when molar concentration is unity. Second difference, this is dependent on initial concentration of reaction. Whereas just now we have seen the rate constant K, it is independent of molar concentration of reactant. Third point, let us define their SI units. The SI unit of rate of reaction is mole, liter inverse, second inverse. Whereas the rate constant K, its unit depends on order of reaction. Now what is the meaning of order of reaction? That we will be discussing in our next video. Now when we have studied rate law, that is the dependence of the rate of the reaction on the molar concentration. Now we have to give its expression also. So let us study rate law expression. Rate law expression is an expression in which reaction is given in terms of molar concentration of reactant with each term raised to some power which may or may not be equal to stoichiometric coefficient. Like, let us consider our reaction A plus B plus C giving the product. Now where A, B and C are the number of moles involved, or they are the stoichiometric coefficient. So how we will define the rate? Rate will be equal to K into molar concentration of A, molar concentration of B and the molar concentration of C raised to the power A raised to power P, B raised to power Q and C raised to power R. Now here A and P, B and Q, C and R may or may not be equal. Now why this difference comes? This difference comes because the rate of the reaction is basically determined by the slowest step which occurs during the reaction mechanism. For example, consider the reaction nitrogen dioxide reacting with fluorine to give nitrile fluoride. So from this expression, we can write the rate equals to K into NO2. Stoichiometry is 2, so we'll take power 2 into F2. But it was found that when the experiments were actually done, and it was found that rate do not follows this expression. Instead, the rate is equal to K into molar concentration of NO2 and molar concentration of F2. Now why this difference came? This difference comes because of the reaction mechanism. This reaction occurs in two steps. In first step, nitrogen dioxide reacts with fluorine to give NO2F and fluorine. This is the slow step. Remember always, the slow step is the rate determining step. It is also called as RDS. You have to remember this fact that always the slowest step will be the rate determining step. Second step now. Step 2, it is NO2 plus F. This one, it will react, but this reaction will be fast, giving nitrile fluoride. Now the rate was decided by which step? The first step. And it was a rate determining step. Therefore, we are taking the rate as rate equals to K, molar concentration of NO2 into molar concentration of F2. So we can redefine the rate law as expression which describes the reaction rate in terms of molar concentration of reactant taking part in the slowest step, because it is the slowest step which will determine the rate of the reaction. So we can redefine the rate law. Overall, we can say that always rate law is an experimentally determined factor. We cannot write the rate law from the given balanced equation. We have to know the rate determining step. So let us consider the reaction which I have written previously. AA plus BB plus CC giving the product, where A, B, C, these are the reactants, and small a, b, c, they are the stoichiometric coefficient. For this reaction, how can we write the rate law? Rate equals to K into A raised to power P, B raised to power Q, C raised to power R. Remember, P, Q, R may or may not be equal to A, B, C. So these values P, Q, R comes from experimentally determined factor, and it comes from the rate determining step, which is the slowest step of the reaction mechanism. So in today's video, we have discussed about rate law, we have discussed about the rate constant, and we have also seen the difference between rate of a reaction and rate constant. That's all for the day. Thanks for joining. Have a nice day.